Hey everyone, today we're going to do longest word in dictionary. It's marked as easy, but I really don't think it's an easy question. Given a list of strings, words, representing an English dictionary, find the longest word in words that can be built one character at a time by other words in words. If there is more than one possible answer, return the longest word with the smallest lexicographical order. If there's no answer, return the empty string. Okay, cool. So here we have an input. Words, right? As you can see, each word in this words array builds up on the previous one. Okay, so W goes to WO, WOR, WRL, WRLD. So the first thing that comes to mind is a trie. Okay, whenever you have words, dictionaries, characters that kind of go in order, think about trie structure. Okay, and a trie structure is nothing too crazy. You can think of it as like a hash of hashes. We just have W goes to O, and O goes to R, and R goes to L, and L goes to D, and D is the last word, so we have some kind of denoter. This is the last word. Okay, and that's like a very basic way of creating a trie. All right, actually, each of these keys will also have this end denoter because each of these is actually its own word. So this would have its end denoter. You know, this would have its end denoter. And this would have its end denoter. And this one too. Cool. So this is more what it looks like. And then basically we can traverse basically through this try to find the longest word. But it's much easier to create a custom class and do that with helpers. So we need two classes. We need I'll leave this open. Actually, we need a class that is a try, right? And class try, define init, take self, and basically all it is a root, and that is a try node. Okay. Then we have a try node. This is the same thing. Define init self. Okay, a node has children. So this is a node, W, and it has two children in this case, right? It has the end denoter and it has the O, which is a whole other node. So self.children we can store as a hash, right? And this hash will be from character to node. Self.isEnd will basically satisfy this denoter we're talking about. So this will be false by default. And self.word I actually like to include also because rather than having to traverse backwards from where you are, you can just know what word you just formed. So if isEnd is true, we'll also have a word that is not an empty string. Cool. So those are our two classes or structs, and we now have to define some helper methods on those. The first helper method should be, insert. So you want to insert a word into a try. So you have insert, self, and the word, right? Cool. So here our current is our self.root, right? And we'll say, okay, for character in word, right? If current.children has that car, right? Oh, sorry, if car not in our children, right? Then we need to put it there, right? So we'll do current.children of car equals a try node. And then we'll move our current to be our current.children of car. And then at the end of it, we'll have gone through all the characters in that word, right? And so now we know that this node that we're at current is going to be our last node in that word. So we can say, okay, current.isEnd is true, and current.word equals the word we wanted to insert. Now we have like our basic structure. We can kind of fill out this longest word solution method. So we can say, okay, first create a try, right? Our try is just an empty instance of our try class, right? Then we say for word in words, right? We want to fill in that try. So we'll do try.insert word. Easy, right? Now we have a try full of those words. Now we want to return try.longest word, right? And the reason why we don't implement, longest word in the solution is because the try should know its own longest word. It's not the solutions class's responsibility to get the longest word out of a try. The try should have a helper method that defines the longest word of that try. And so I'm going to actually just comment this out. And this will be our solution. We have to just now define this longest word method. So there are two ways we can basically traverse this try to find out the longest word. We can do a breadth first search where we look at all the different, level by level, all the different words, or we can do depth first search, take one path and go all the way down, capture its best word, and then do that for all the paths, and then compare all the best words. I'm going to do breadth first search. So if you want to do depth first search yourself, that could be a good exercise. I'm actually going to use whenever you're talking breadth first search, we need to use a queue. So I'm going to have the queue here. It's going to be at collections.deck, and we're going to initialize it with our self.root, right? Our root of our try, right here. It's an empty tree node. Actually, it's not an empty tree node. It's all the words have been inserted. Okay, so now I'm going to say, okay, our best result is so far an empty array. At the end of this, we want to return an empty array. An empty string. At the end of this, we want to return, what we have so far. And so what we're going to do in this loop is we're going to update our result when possible. So we'll say, okay, while there's a queue still, right? We want to get our current node, right? And that's going to be just queue.popleft, right? And the reason we use a deck is because popping and from the 0th index and the last index is constant time. That's what we're going to do in this situation. So, it's faster than popping at a particular index in a list. Now, if we remember that we stored node's children as a hash from character to a node or a try node. And so what we want to do here is basically say, okay, for child node in current nodes dot children dot values, because we want actually node values as opposed to cars, right? I want to say, okay, is our node an end word? If it is an end word, we can use it to chain end words together to get our longest word. So if child node dot is end, right? This means we can chain things together, right? Then we'll say if the length of our child node dot word is greater than our length of our current word, longest word, which is result, then we want to update our result to be equal to our child node dot word, right? Now, an extra complexity here is it says, if there's more than one possible answer, return the longest word with the smallest lexicographical order. So we have to actually have an additional condition here. It says, if the word is longer than it, or if they're equal, right? But the lexicographical order is less. So we'll say if child node.word is less than result. Then we update the result, and then we return this result at the end of this looping. So let's go over what we did here. We saw that we have to get like a sequence of characters and words to form other words, and so we thought of a try. So we defined our own class of a try, and this class of a try has a root value, and that value is a class try node. So a try node is basically contains 3 different attributes. The first attribute is a children hash, where the key of this hash is a character, and the value of the hash is the node, the node that follows. We have an attribute that indicates whether this node ends a word. So this sequence of previous parent try nodes ends in this one is now an end word, and we store the word that it would end in if it is an end word. Okay. Then we created a method that says, okay, given a try, insert this word. The insert method basically tries to traverse the try for every single character in that word. Once it finds a character in the word that's not in that try sequence, it adds it in, and does that kind of by reassigning currents to its child node. And then we define this longest word method within the try class that says, okay, given a try, find its longest word. And that method belongs in the try class because of it's the responsibility of the try to know about its longest word, not the responsibility of the solution. So the solution can just leverage the try's knowledge of its longest word to get the answer. So here in the solution, we basically initialize or instantiate a try. For every word in our words array, we insert that word into our try, and then we use our try, which is fully populated, to find the longest word. Now, the longest word method is probably the bulk of this work. And so basically what we want to do is, okay, say, hey, create a queue, right? We're doing this breadth first search, create a queue, start it with our root of our try, right? Pop the root of our try, right? And say for every child in there, if that child node is an end, and we want to consider these end child nodes only because we want to find consecutive words that build up on one another. It says, find the longest word in words that can be built one character at a time by other words in words. That's why we check if it's a node end, then we know we can build on it, right? So now if that word is an end, then update our result basically. So if our result is smaller than our new end word, then update it. Or if our result is the same length of our end word, our current end word, but our current end word is smaller lexicographically, then also update result. Then we return result, and we pop all the way back up, and we return that value. So let's run this actually, and see how it goes. Empty string, no. Okay, empty string. So how do we do this? So our result is basically assigned to child node.word, and our child node.word is initialized at an empty string down here. And so for some reason, child node.word is empty string. So that's because once we finish inserting every single character into our try, we actually have our current. This somehow got deleted, so our current is end is equal to true, and our current.word equals the word we've just iterated through. So now let's run the code and see if this debugging actually helped. So boom, 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 wrong answer, W. Okay. So what we're doing here is so what happened was we're only getting this first word, and that's our longest one. And the reason is because we're not appending our other possible nodes to our queue in this longest word method. So basically what we have to do here is say, okay, queue.append child node, right? Otherwise, we'd only go through the queue once because we're only assigning one value to it ever. So now this will work, I promise. Cool, yes, thank God. So, yeah, now let's use this test case that they have here, where two words have the same length but are lexicographically different. So let's run that and see if we get apple. Yeah, and that's because of this section right here. So if we were to get rid of this section, let's just see, it'll show up. We'll see what it says. It says apply, right? Because it's the first one. But actually, we need it. Sweet. Okay. Thanks, guys. I hope you enjoyed this one. It's really good to learn about tries, or at least get familiar with how to use them. I am personally not that great at them, and so this was really good practice for me. The other tricky part about this question was knowing how to traverse the try, and because we had to connect full words to create the next word, it was a bit tricky, that conditional. If child node that is an end word, then we want to consider it. But yeah, hope you enjoyed. This is definitely not an easy question. I had a lot of trouble, and yeah, thanks for joining.